Welcome to this 8th video of lesson Similarity of Mathematics Part 2 of Standard 10. In previous videos, we have seen how to solve question number 1 to 5 from practice set 1.2. Now we are going to solve 9th and 11th sum, which are little bit different or little bit difficult from the other sums. Now when you will solve these three videos, similarity part number 6, 7 and this 8, you can solve the remaining sums from the practice set 1.2. Okay, if you are still any doubt, you can give me in comment box. I'll surely make the video on the sums which you want to be solved and put it on the YouTube. Let's see now question number 9. Now what is this question number 9? In question number 9, it's given that in triangle ABC, BD bisects angle ABC. BD, this bisects angle ABC, and these are the lengths given in form of x, and we have to find value of x. Okay. Now x we can see all this in segment AB is x, BC is x plus 5, AD x minus 2 and DC is x plus 2. So to find x and being this BD is bisector of angle ABC, we need to use angle bisector theorem in triangle ABC. So let's start this answer part. Let's write in triangle ABC, BD or ABD bisects angle ABC. Okay, this is given to us. Therefore, by angle bisector theorem, angle bisector theorem. What is this theorem tells us? That angle bisector makes two parts of its opposite side, and the ratio of these opposite sides is equal to the ratio of its remaining sides. So these are the two parts of opposite sides, BD, AD and DC. If we are taking in this sequence AD upon DC, then it is this ratio is equal to the ratio of the remaining sides. Now what is the side on the side of this ray BD? If AD is on the upper part, here it is AB. So we have to take the ratio of AB, and the remaining side of the angle ABC is BC. Okay. So now let's substitute these values over here. AB is given to us x upon AD we want. AD is given x minus 2 upon DC is x plus 2. Yes, and here it is AB, which is to be x and x plus 5. Now let's simplify these two ratios by doing cross multiplication. We have to multiply this x with x plus 2 is equal to this x minus 2, and another bracket it is x plus 5. So let's take this product on this side. Let me use this part of the board. So when you take the product x into x, it is going to be x square plus 2x is equal to, now here we have to multiply this x with x, that is x square. If we are using the identity, which identity? Say its identity is x plus a into x plus b. So where the two brackets are such that where the first term is same and but the second term is different, its product is square of the first term, that is x square, plus you have to add these two numbers a plus b and multiply with the common first term x, and then take the product of a into b. So here you need to take addition of second terms, multiply by the first term and take the product of second term. So using this property, you can use here x into x, x square. Now what is minus 2 plus 5? Minus 2 plus 5 is going to be plus 3. So it is plus 3x. Okay, this 3 we will multiply with the first term x. Okay, and plus you have to take the product of these two. What is the product of these two? Minus 2 into 5, it is minus 10. So it's going to be minus 10. So if you are using this property, you can write it directly. Otherwise, you can take product with x into x as x square. Okay, or the alternate method is what? You can use this x into x is x square. Then x into plus 5 is going to be plus 5x. Then multiply by minus 2 to the x, it is minus 2x. And then minus 2 into plus 5 going to be minus 10. And when you simplify this, plus 5x minus 2x, you can get this term plus 3x. Whichever is easier for you. So x square plus 3x minus 10. by any one method which is comfortable for you, you can find that product of two brackets on the right side. Okay. After this, let's simplify it further to find the value of x. Now we have observed that on the both sides we have x square terms which can get cancelled. Okay. Therefore, now we get 2x is equal to 3x minus 10. Now, if we take 3x on the left side, it will become minus. Then we can get minus x. So, whatever equation we have got, if we have variables on the both sides, just do one smart tip, that see wherever the variable of x is bigger and keep it there only. Means here 2x and right side it is 3x. So 3x is bigger than 2x. So keep 3x here only. Take my 2x here as minus 2x and then minus 10 on the left side. Transpose it as plus 10. Here what will happen? It will avoid of getting sign of variable to be negative, because when you get negative x, there you may go wrong. You are there's more possibility that you will go wrong. So to avoid such mistakes, do this easy thing. So 3x minus 2, it is simply x and it is x is equal to 10. That's why x is equal to 10. This is your answer. Value of the x is 10. This is your answer statement. So using this angle bisector property, we have got this two ratios which are equal. Substituting values, we have got this equation. Okay. So here we have used some knowledge of geometry and some knowledge of algebra we have used over here. Okay. Now let's see how to solve question number 11. Let me rub this part, so I can use this part over here. Okay. So let me draw the figure. As the figure is not given in the question, we need to draw our own figure. But let's read what is the information given. Now in triangle ABC, ray BD bisects angle ABC and ray CE bisects angle ACB. If segment AB is congruent to AC, then prove that ED is parallel to BC. In first go, something you will understand, something you may not. But what you have to understand, first thing, if there is a triangle ABC, where these two sides AB and AC are congruent. So let's draw one isosceles triangle where these two sides are equal. So this is your AB and AC are equal. Now see, BD bisects angle ABC. This is angle ABC. This is bisected by ray BD. So let's draw ray BD. So these two are equal parts. Okay. And CE bisects angle ACB. So CE should be drawn in this direction. This is your E. Okay. So as this base angle, when these two sides are congruent, this base angle is congruent, both angles are congruent. So bisecting means this also will make two equal parts. So all these four angles are equal. And this is CE bisecting. Now you have to prove that ED, where is E? This is E and D. So this, if we join this ED, you have to show it is parallel to BC. Okay. Now, in which case ED can be parallel? If AE upon EB is equal to AD upon DC. If we find these two ratios are equal, then we can prove this. So, let's do that rough work part. Students, you can do this rough work part. You should do this rough work part by pencil. So, this whatever you will write will not be considered as the main answer. And from this rough work, you have to write the main answer. That main answer will be given you marks. Okay. So what we have to prove? So to prove ED, if you want to prove ED parallel to BC, we need to prove AE upon EB. Is it so? How can we prove this? To prove this, we have to prove EE upon EB is equal to AD upon DC. So if we can prove this, how can we prove this? If we can prove this, then we can prove this is parallel by converse of B.P.T. So to prove this, this is the target. Now the target has been shifted from parallel to this, because when we prove this thing, we can prove this easily by using converse of B.P.T. Now for proving this, how to prove? Let's use the information that BD is bisector of angle ACB. Okay. Now just concentrate on this part that BD is bisector of angle ABC. Now using angle bisector theorem, what we can say that now BD is bisecting angle ABC, the opposite side is AC. So AC is divided into two parts, AD and DC. So by using that angle bisector property, we can say AD upon DC is equal to the remaining sides now AB upon BC. AB upon BC. This we are taking only because that BD is bisector of angle ABC. Okay. Now this can be say statement number 1. And when CE is bisecting this angle ACB, the opposite side AC is divided into two parts. And if we take the ratio of these two parts, AE upon EB is going to be equal to the remaining sides are now AC upon BC. AC upon BC. Now if you will check that AE upon EB, here AE upon EB is equal to, we have to prove AD upon DC, AD upon AC. Means we have to prove these two ratios to be equal. To prove these two ratios to be equal on the left side, can we show these two ratios on right side equal? Check the numerator. Numerator is AB, numerator is AC. Denominator is BC and BC. So already the denominator is equal. So there is only question about AB and AC, and it's given to us that AB and AC are equal. So if these two numerators are also equal, denominator is already same, we can show right side is equal, hence left side equal. If left side is equal, we are showing these two ratios are equal, and that as these two ratios are equal, we can say by converse of B.P.T this line is parallel to ED is parallel to BC, that to prove. Okay. So after this, now let's start solving. So thought process goes in this direction, but the presentation process goes in opposite direction. So we have to start with this part. Okay. So proof part, we start. Actually, as this is statement, we should write the given and to prove also. Now your given can be nothing. You can start from here to here. It is your given, and then this prove that is this much part. So you can just copy this part as given. I will just write over here given, and then you can copy that box part, whatever there, and to prove it is okay this part. Okay, so this you have to write in your answer paper. Okay, this is your question in question paper, and you have to draw the figure. You have to write the given to prove from the question, and then yes, you can start now the proof part. Okay, so now we will start with in triangle ABC. Okay, ray BD bisects angle ABC. Ray BD bisects angle ABC. Why we are saying so? It is given. So to write what is given, whatever given part, that should be mentioned initially. Okay, therefore by angle bisector theorem, what we have to prove that AD upon DC, which we have written over here. So you can copy the same, AD upon DC is equal to AB upon BC. As we have to use this statement afterwards, we have to say number 1, and by angle bisector theorem. Okay. Now, similarly, ray CE bisects angle ACB. Therefore, now this another ratio AE upon EB. AE upon EB is equal to AC upon BC. Statement number 2. Okay, similarly we have written, so no need to write this angle bisector theorem. Now, so we have to show this right side two ratios are equal. That we can show as AB and AC is equal. Okay, okay, but AB is equal to AC. Statement number 3. It's given. It's in the given part that these two segments are congruent, their lengths are equal. Therefore, now from the statement number 1, 2 and 3. Okay. So we will write here now these two equal. Let me run the fourth part here. Now we know what is to be done over. Therefore, now AB upon BC is equal to AC upon BC. So from 3 we have written this. Okay, say statement number 4. This is from 3. In 3 it is AB and AC are AB and AC equal. We have divided these equal parts by BC. And now this is your right side of your statement number 1, 2, 1 and 2. Okay. And therefore now we can say the left side AD upon BC is equal to AE upon EB. So this we can write from statement number 1, 2 and 4. From 1, 2 and 4. Okay. So fourth we are saying the right sides are equal, hence the left sides of the statement number 1 and 2 are also equal. And now it is when these two sides are in proportion because of this line ED, therefore we can say therefore ED is parallel to BC. ED is parallel to BC. The reason is by converse of B.P.T. Basic proportionality theorem. Don't use the word theorem after B.P.T. because T means theorem only. Okay. So in this way we have proved this ED is parallel to BC. Now with the help of this theorems, the way of presentation and the thought process which I explained you can solve the remaining sums from this practice very easily. I hope you have understood all these concepts clearly. Please give me your likes and comments. And if you are not yet subscribed to the channel, please subscribe. Thank you.